This happens every couple months. Somebody compiles hello world in Rust and in C, takes a screenshot of Rust binary size, posts it on Twitter with a clickbait title like Rust is bloated and slow, throw it away. And then it causes another international conflict between furries and the neckbirds. And then the cycle continues. So let's put this to rest. Let's figure it all out. Let's see if we're comparing apples to oranges. Here we have hello world in C. Let me remove this. This is a little bit of a foreshadowing. And here we have a hello world in Rust. And let's compile both of them. Let's compile Rust one into hello underscore R. And let's compile C1 into hello C. Let's go to the terminal and look at them. And lo and behold, indeed, hello R is almost 4 megabytes and hello C is 15K. So what's going on? Let's try to crash the program. And I mean, crashing your C program is very easy. All you need to do is sort of create an array of maybe a couple elements and try to print something maybe slightly out of bounds, like just a little bit of out of bounds. And if you compile your C program again and you run it, yes, you get a crash. And as you can see, this crash doesn't really tell you where we crashed. It's just like this executable somewhere tried to access something out of boundary. And the way you do something similar is Rust is actually a little bit more mouthful. So you can create an integer, and then I'm just not even gonna pretend that I'm typing it from memory. I'm just gonna straight up like copy paste it from another monitor, which just creates a slice of 32-bit integers that you create like from reference of something, and something is I on the stack. And then if you try to print this and something from this array also out of bounds, and you compile this is not foo, sorry, this is a, yeah, when you try to compile it and also run hello R, you will get a Rust panic, which is pretty much a runtime crash, and it tells you that you can see a backtrace, something that is not possible with C program by default. And on top of that, it tells you exactly that you have an index out of bounds, right? And it tells you that the length is 1, but the index is this. So not only you have a backtrace, by the way, let's look at it. Let's look at it, and you can even get a full backtrace if you run it with full, and there's just a lot of information exactly what happened. But having automatic array bounds checks, this is very helpful. This is something every modern programming language just has by default. So this is the first reason, and you can sort of strip it down. So if you do Rust C, and let me autocomplete this, and you pass -C, capital C, strip equals debug info to your Rust file, and you recompile the file, now if you take a look at the binary size, it's already almost 10 times lower. So now it's only 400K, while C program is still 15K. So, you know, already quite a bit closer. So what's next? If we look at both of the executables, you can see that they are dynamically linked. And the C program actually takes all of this functionality from libc, which on my system is glibc. And while Rust program also links against libc, it probably only does it for syscalls, if I were to guess. I actually don't know for sure. And if you look at objdump, so if you look at symbols that executables have, you can see that the hello C program is quite small. If we do the same with Rust, you will have a lot of symbols. And what is this? Like underscore capital Z N4 something something FMT upper lower. What this tells us? Well, first underscore Z and blah blah blah, and this weird ass name. This is something that's called mangling, and the compiler takes namespaces and symbols and it produces a unique names that don't clash when you compile them into an executable. Another thing this tells us is that Rust C takes Rust standard library and it actually statically compiles it into an executable. So when you look at the size again, not at the size, when you look at LDD, you can see that our Rust executable, it's not linked against anything that resembles a Rust library here. Even though when we look at the code, we are able to use all of this functionality like slices. We are able to see array bounds check. We can also do something like we can also use like vectors and whatnot. And vectors are actually dynamic arrays in Rust. Let's make it fair by compiling Rust executable dynamically against the standard library. And in order to do this, you can again use a Rust compiler. So if you pass it another flag, prefer dynamic equals yes, and compile it, you will get our executable. And now if we compare the size, look at that. Now it is actually 8K against 15K from C. So, who is bloated now? And maybe before I do it, let me remove the code that crashes. So it's just a plain old hello world like it used to be, and same in C. So remove this, and yeah, let's compile GCC. Let's recompile our Rust program without any, did I save it? Yeah, I think I haven't saved Rust file. Yeah, I haven't. So let's recompile it. Let's again check the sizes. Yeah, we can see that Rust is now very small. If we run our hello.c, we get hello world. And if we run our hello.r, we get an error while loading shared libraries. libstd c blah blah blah, c6, c something 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 cannot open shared library. If we look at LDD for Rust program, we will actually find this libstdc is now dynamically linked, and it is not found. But before we find it, let's look at objdump again and look at this, how small it is now. Now it has just very, very, very few symbols just to start our executable and get it going. And everything else will get linked dynamically. So where is this library located, this magical library that my operating system can't find? Well, first we need to know that this shared library is located in our Rust app toolchains. And in my case, it's Rust app toolchains nightly lib. Yeah, there it is. No, there it is. This is the one we're looking for. So we can either copy this shared executable near our file, or we can just say LD library path, something like this. So we can prepend LD library path with path to this folder and run our executable, and now it works. So there you have it, an actual honest comparison between dynamically linked Rust program and dynamically linked C program, which when you completely equalize the surrounding environment, you will see that default Rust executable is actually smaller. So again, just to summarize, do not compare apples to oranges, and just learn some fucking programming already, okay? Thank you.